Good evening, all. Hope you all are really waiting for today's webinar. So we are officially starting. Hope you all are ready for that. So this is Integrated Civil Engineers Council. Every month we are conducting one particular webinar in which we'll be focusing really on any relevant topic which is in industry or which is very well discussed in our construction profession or which is very relevant to public. So as part of our technical knowledge sharing and gaining vision, we are conducting this webinars. And this is particularly exclusively for civil engineers. At the same time, this can be benefited by all those who are interested in knowing more about civil engineering profession. ICEC, officially, I'm giving a brief intro about ICEC. This is a professional platform wherein exclusively members having B.Tech degree and above will be able to take membership. At the same time, this platform is open to young engineers who are graduating from engineering colleges, which institute are having AICTE approved courses, B.Tech degree courses. The students of that particular colleges can be part of ICEC as pre-associate members. And right now, Integrated Civil Engineers Council, we are in Kerala, as well as we have an international forum in UAE. And near soon, we will be launching in Chennai and other metro cities of India. And immediately, we will be having our annual event plus Engineers Day celebration happening on September 15, which is happening in ADLEX Convention Center, wholeheartedly welcoming everyone, every participants of today's webinar for the particular September 15th event happening in ADLEX Convention Center. And on that particular day, we will be having Dr. E.Sreedharan as one of our chief guests. So hearty welcome to all of you to the particular webinar happening today, as well as for our event, September 15 annual event happening in the month of September at ADLEX Convention Center, reminding it again. And today, we have one of the prominent engineers who's an expert in tunnel engineering with us. And we all know that recently we faced one of the biggest construction challenges we recently faced in the district of Wayanad, which is Wayanad twin tunnel work. നമ്മളെല്ലാവരും എഞ്ചിനീയേഴ്സ് എല്ലാവരും വളരെ കീൻലി ഈഗർലി വെയിറ്റിംഗ് ആയിരുന്ന സക്സസ്ഫുള്ളി പോകേണ്ടിയ ഒരു ട്വിൻ ടണൽ പ്രോജക്റ്റ് ആണ്. Every project will be having its own challenges during its execution phase. Definitely, it was well discussed in all the medias, even among public. So, അതിനകത്ത് എന്താണ് സംഭവിച്ചത്? What could have done better? ഇത് project as a whole failure ആണോ? ഇത് നമ്മുടെ ക്ലൈമറ്റ് ആണോ പ്രശ്നം, മണ്ണാണോ പ്രശ്നം, എന്താണ് സംഭവിച്ചത്, എഞ്ചിനീയേഴ്സ് ഫെയിൽ ആയതാണോ, ആ പെർട്ടിക്കുലർ ടീം ഫെയിൽ ആയതാണോ, ഇതൊരു മാൻമെയ്ഡ് ഡിസാസ്റ്റർ ആണോ ഓർ നാച്ചുറൽ ഡിസാസ്റ്റർ ആണോ? ഒരുപാട് കാര്യങ്ങൾ ചർച്ച ചെയ്യപ്പെട്ടു. ഇൻ മോസ്റ്റ് ഓഫ് അവർ വെബിനാർസ് ഹാപ്പനിങ് ത്രൂ ICEC's വെബിനാർ പ്ലാറ്റ്ഫോം നമ്മൾ ചൂസ് ചെയ്യാറ് ഇതുപോലുള്ള റെലവൻറ്റ് ടോപ്പിക്സ് ആണ്. ദിസ് ഇസ് ബേസിക്കലി നമ്മൾ വൺ ഓഫ് ദ ഇൻഡസ്ട്രി എക്സ്പേർട്ടിനെ എടുത്തിട്ട് തന്നെ ഇങ്ങനെയുള്ള ടോപ്പിക്സ് ഡിസ്കസ് ചെയ്യുന്നത്. നമ്മൾ ബേസിക്കലി പബ്ലിക്കിൽ നിന്നും എല്ലാ എഞ്ചിനീയേഴ്സിൽ നിന്നും ഫേസ് ചെയ്യുന്നതായ ബേസിക് ക്വസ്റ്റ്യൻസ് എങ്കിലും നമുക്ക് അഡ്രസ് ചെയ്യാൻ പറ്റണം. ഒരു അവയർനെസ് ജനറേഷൻ. അറ്റ് ദ സെയിം ടൈം വി ഹാവ് ടു ലേൺ from our own mistakes, at the same time from our own experts. Is this for the first time something happening like this, or is it very common, or is there anything specific to be addressed while going forward with this particular twin tunnel project? So with great pleasure and with proud, we are saying that today we have one of our members, ICEC's prominent member, who is taking part and being our speaker for today's webinar, Engineer Vijayakumar sir. He is actually joining us from Delhi, all the way from Delhi, supporting all the engineers here in Kerala. So, നമുക്ക് അദ്ദേഹത്തിൻ്റെ ഒരു ബ്രീഫ് ഇൻട്രൊഡക്ഷൻ ഞാൻ തരാം. He is having a total of experience of around 38 years of experience. He is a senior tunnel, geotechnical and structural engineer. And he is having experience in India as well as abroad. He is currently serving as the head of the Department of Tunnel and Geotechnical at Ramboll, one of the premium and one of the prime consultants in India. Actually, Ramboll is a Denmark-based company, and he is serving up as the head of the department for this particular tunnel wing itself. And it is a leading multidisciplinary team which is dealing purely with metros, roads, railways, and hydropower projects. And his expertise is spanning in tunnel, underground stations, dams, barrages, and hydropower facilities. He is an IIT Delhi alumnus with M.Tech in rock engineering. We have very, very limited engineers who are specialized in rock engineering, and today we are having one among us. And he is also pursuing a PhD at IIM Shillong on safety management of underground tunnel project. So, rightly speaking, ഇന്നത്തെ ഈ ടോപ്പിക് എടുക്കാനായിട്ട് one of the best engineer from India ആണ് നമ്മുടെ ഇന്ന് ഡൽഹിയിൽ നിന്ന് നമുക്ക് വേണ്ടി ടൈം സ്പെൻഡ് ചെയ്യുന്നത്. His expertise itself is in tunnel engineering, and he's doing a PhD in safety related to tunnel engineering. So, over to you, sir. Wholeheartedly on behalf of all entire ICEC members as well as non-ICEC members who are keenly waiting to listen to you. Over to you, sir. Hearty welcome to today's webinar. Vijayakumar, sir.
Thank you,
Very good evening, sir.
Good evening. Very good evening.
Yes, sir.
So thank you, ICEC, and especially Vidya ma'am.
Yes, sir.
Divya ma'am.
Yes, sir.
So
Sir.
shall I share my screen?
Yes, sir. Sir, screen കുറച്ചുകൂടെ ഒന്ന് ബാക്കിലോട്ട് വെച്ച് tilt ചെയ്ത് കഴിഞ്ഞാൽ your full face will be visible to all of us. Yes, sir. Yes, sir. Perfect.
Now
Thank
it's
you.
fine. Yeah.
Yes, sir. Thank you so much.
So I will share my screen. Is it visible, ma'am? Yeah.
It is getting shared, sir. One second. Yes, sir. Right now it is visible. You can go to slideshow.
Yeah.
Yes. So please, everyone, please listen. We will be having this technical presentation till 9 o'clock, and after 9 to 9:30, we will be having question, answer, and interactive session wherein you are free to ask your own question in any language. Never mind about your language or anything. നമ്മുടെ സ്വന്തം കാലിക്കറ്റിൽ നിന്നുള്ള ഒരു മലയാളി തന്നെയാണ്. You can ask any technical related question to him. Over to you, sir.
Yeah. One second. Visible?
Yes, sir. It is getting shared. Yes, sir. Perfect. Go ahead, please.
നമ്മളിന്ന് സംസാരിക്കുന്നത് മാഡം പറഞ്ഞ പോലെ കല്ലാടി ലാൻഡ് സ്ലൈഡിനെ പറ്റിയിട്ടാണ്. അപ്പം നമ്മൾ ഇതിന്റെ ആദ്യ ഇൻസിഡന്റിനെ പറ്റി നമ്മൾ പറയുന്നില്ല, ഇവന്റിനെ പറ്റി നമ്മൾ സംസാരിക്കുന്നില്ല. നമ്മൾ സംസാരിക്കാൻ പോകുന്നത് ഇതിന്റെ മെക്കാനിക്സ് ആണ് ആദ്യം. അതായത് തിയറി, എവിഡൻസ്, ടൂൾസ്, കേസ്, ആക്ഷൻ. ഈ ഒരു ഫ്ലോയിലാണ് നമ്മൾ ഇതിനെ ഡിസ്കസ് ചെയ്യാൻ ഉദ്ദേശിക്കുന്നത്. ആദ്യം പ്രസന്റേഷൻ റോഡ് മാപ്പിനെ പറ്റി പറയാം. ഈ ഡെക്ക് നമ്മൾ ആകെ 7 ഡിവിഷനായിട്ട് ഡിവൈഡ് ചെയ്തിട്ടുണ്ട്. ആദ്യത്തേത് തിയറിയാണ്. വാട്ട് എ ലാൻഡ് സ്ലൈഡ് ഈസ്, ഹൗ ഇറ്റ് മൂവ്സ്. അതിന്റെ ലാൻഡ് സ്ലൈഡ് എന്താണ്, അത് എങ്ങനെയാണ് മൂവ് ചെയ്യുന്നത്, എത്ര സ്പീഡിലാണ് അത് മൂവ് ചെയ്യുന്നത്, അതുപോലെ വെള്ളത്തിന്റെ ഹൗ ദ വാട്ടർ കൺട്രോൾസ് ദ സേഫ്റ്റി മാർജിൻ. അതാണ് ഒന്നാമത്തത്. ഈ രണ്ടാമത്തത് ടെറൈൻ. ഈ വെസ്റ്റേൺ ഗാർഡ്സ്, അതായത് വയനാട് ഉൾപ്പെടുന്ന സ്ഥലത്തിന്റെ ലാറ്ററൈറ്റിക് പ്രൊഫൈലാണ്. ആ വാട്ടർ സെൻസിറ്റീവ് ആണോ, അത് സ്ലോപ്പ് മെറ്റീരിയൽ എങ്ങനെയാണ് നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത് രണ്ടാമത്തെ സബ് ഡിവിഷനിലാണ്. ഇത് രണ്ടും കൂടി ചേർന്നിട്ട് നമുക്ക്
One second, sir. There is a few participants joining from other states too. Is it okay if we can take it in English? It will be comfortable
we
for
can,
them.
we can.
Thank you so much.
So, yeah, there are 7 divisions in this presentation. The first and second dealing with foundation, that is theory and terrain. Theory means what a landslide is and how it moves, why water controls the safety margin. That deals in under subdivision theory. And terrain, what is the type of material or what is the profile there in Wayanad, that is in Western Ghats. and water sensitive slope material. It's a water sensitive slope material. Then evidence and tunneling, 3 and 4, actually the toolkit, investigation, instrumentation, remote sensing, risk framing and modeling. Then tunneling, we will discuss how portal cards, TBM and NATM. I think NATM they have used one of the methods in tunneling. Excavation change the slope system. Now, the next one is mitigation. As per the literature and my experience, there are 45 methods for mitigation, but we will go through one by one. If the time permits, we can discuss in detail. Then we will go to case, that is Kalladi event, its facts, chronology, consequences, competing interpretations. The last one is action. What should we do? Then evidence-based and important caution. So these are from the text we will discuss. This is Kalladi case briefing and landslide in practice. I told you, 45 methods are there, that mitigation catalog. So landslide dynamics, classification, monitoring, susceptibility and risk, soil nailing, bioengineering, numerical modeling comes under theory, practice and modeling. And this points, location, preliminary event facts, rainfall and groundwater, competing interpretation, warning, construction, governance lessons come under Kalladi case briefing, and investigation, groundwater, shear strength, stability analysis, 45 stabilization methods, construction control, case history learning. That comes under landslide in practice. So the caution is, please note down this point. Reported casualty, rainfall, and warning information is presented as a dated public record. The expert committee's final reconstruction should govern any legal and definitive attribution of cause. Now, the executive takeaways. There are 5 points which I want to highlight. Trigger is not a cause. Trigger is not a cause. Intense rainfall may have triggered failure, while geology, slope disturbance, drainage, loading, and warning response practices shape susceptibility. Then mechanism first. Slip surface geometry, classification, water jam, movement mode must be established before stabilization is chosen. Water is central. I told you, water is the central part because the material available there is a water sensitive material. So we'll discuss more about that in the coming slides. Sorry. Then surface runoff, infiltration and pore pressure commonly control the safety margin. Drainage is often the first line of defense. The next is temporary cracks. Temporary works. Temporary works means usually we will not consider in the permanent design. For example, portal cuts, muck handling, stockpiles, and monsoon sequences. This can create risk not present in the permanent design. Risk information must change decisions. Monitoring only protects people when threshold, stop work authority, evacuation routes, and communications are operational. So let us start with the mechanics, physics. So there are four points I want to discuss. One is the movement type, second is the velocity, then third factor of safety, and then last one is the role of water. Okay, the same flow will continue everywhere throughout the presentation. So what is landslide? So this is the basic. So sorry, geotechnical engineers know these things, but being a big forum, I would like to start with the fundamentals. So what is landslide? Landslide is a gravity-driven movement of rock, debris, or earth or soil. So its movement can be very, very extremely slow creep, means millimeter per year, to a catastrophic flow, means meter per second. So material, there are three type of three points to be discussed under this this slide. In this slide, material may be rock, debris, earth, soil, or mixed colluvium. We'll discuss all these points. Then movement. There are 6 type of movements: fall, topple, slide, spread, flow, complex. All these points will be discussed in detail. Then rate, the velocity, millimeter per year to meter per second. So what actually the engineering definition is, when the resistance is no longer sufficient, then there will be landslide. Means failure begins when available resistance is no longer sufficient for the driving action in proportion condition. So let us see one by one. First, the field terminology, that is anatomy of landslide. So this is not for the academic purpose. So this is for communication, for mapping, for since from A to Z this is required actually. That's why I have put this slide. So naming parts, these are the cracks, tension cracks. Then this exposed face is called main scrap, minor scrap. Then these are we can see here, upper extension zone, crown and crack. Fresh cracks often precede detachment. So this will detach actually, then tensile stress will be developed there. Then main scrap, exposed head of the rupture surface, main body. See, this is the main body. Then rupture surface. So this is the rupture surface. I think my mouse is visible. This is the rupture surface and foot and toe. So foot and toe is visible here. So naming the part of communication, I told you, for improving mapping, communication, monitoring. It is not for academic purpose. That's why I put this slide here. Then, as we discussed, there are 6 type of movement type. First is fall. Fall means, imagine a rock boulder which is falling from a high level to high elevation to low elevation. So it will bounce or it will roll. So that comes under this category, falls. Topples, I will show you a picture so that it will be easy to visible.
Yes, sir, it is visible.
Yeah. So this is the topple. So topple means there will be some type, for example, basalt. Basalt means there will be a columnar basalt. Once you excavate this will topple. You can imagine that one. So this type of movement mode is called toppling. Then slide. This is the toppling. Here it is mentioned in the second column from the right. And third column, there are 6 columns actually, main columns. And here this slide can be translation along a plane or rotational. So this I will give you a picture. This slide. I hope it is visible. Yeah. So this rock can move along a plane. So it is called planar failure. The rocks are these are the joint sets actually. So it can move along a plane. So this type of movement is called planar or slide. This particular slide is called planar failure. Planar failure. This may lead to planar failure. Then another thing I would like to show you is circular failure. So this is rotational. See, this is rotational. So there will be a surface arc type of thing, and it will slide like this. Then another type of planar failure is wedge failure. I will show you that one as well. Oh. So in this wedge failure, you can see just forming a wedge. So there are 2 planes and third plane, that is the scrap we told. So this type of plane failure is called wedge failure. Now next is spread. Spread means lateral extension. So here it can be seen, lateral extension spreads. Flows means it is remolded. The materials remolded, saturated mass behaves like fluid-like. And the last one is complex. Complex means 2 or more modes in sequence. So either of these, any of these 2 modes or more than that. Now let us see the velocity. We told movement type, then type of landslide, and then the third one is the velocity. It can be extremely rapid, that is catastrophic, escape unlikely. Very rapid, seconds to minutes, severe life safety risk. It can be rapid, minutes to hours. Evacuation may be possible. Then moderate. hours to days. Temporary works may be maintained. Very, very slow. Weeks to years. Maintenance and stabilization possible. Extremely slow. That is detectable by instruments only. So long-term creep. That is millimeter per year or something like that. Now, let us see slide flow transition. A landslide can start as a slide, but on the way, it will mix with loose material, and then finally it can become a flow or debris flow. So that is actually mentioned here. Water-rich failure can begin as a slide, remold, and drain. And drain means it fuel material and continue as a debris flow. Slide means we already discussed about slide. A distinct rupture phase will be there. Coherent block or soil mass. Geometry can back analyze. We can back analyze the geometry. Movement may be rotational or translational. I showed the two pictures. One is for three pictures, planar failure, wedge failure, and rotational circular failure. Mitigation targets slip surface, toe and pore pressure. Flow debris, so this is actually the transition. Flow means high water content, fluid-like transport, rapid channelized runout, boulders and debris increase impact. Mitigation must address runout and exposure. So here we can see the saturation, remolding and entrainment. So it can start as a slide, then consequently it can become a flow or debris flow. Now, what is factor of safety? Oh my gosh. Sorry. So factor of safety, everyone knows that resisting force divided by driving force. So what are the factors which contribute resistance? So cohesion, that is C prime, effective cohesion, friction angle, toe support, nails, angles, and piles. We'll discuss all these points. Demand, what is actually the driving force? Catering means slope angle, height of slope, weight of material, surcharge on over it, erosion and vibration. Water effect. Water effect means it adds weight and reduces the effective stress. So it is multiple way it is attacking the slope or contributing to the driving force. Then design lesson for sensitivity and scenarios, note one best estimate factor of safety. We have to do sensitive analysis instead of doing one best estimate analysis. Means one factor of safety. Once we know the factor of safety, you don't stop the design or the analysis. We have to do sensitivity analysis. If factor of safety is more than one, resistance exceeds demand. Factor of safety is one, marginal or sensitive. If factor of safety is less than one, that means failure condition. See, so this I have taken a picture from a textbook. So this is the slip circle. This is center of the rotation, and this is the tension crack. We will discuss what is tension crack, etc. And so this is the rain infiltration, potential slip surface. So total stress. What is total weight of soil, water, and surcharge? Gamma into H. Or we have to calculate the total stress based on the layering. Then pore pressure U, water pressure acting within voids and fractures. Effective stress sigma dash is equal to sigma prime is equal to sigma minus mu. That is total pressure stress minus pore pressure. Then what is shear strength? Shear strength tau is equal to C prime plus sigma prime tan prime phi prime. So here we can see if effective stress decreases, that is if effective stress decreases means pore pressure increases. Total stress remains same. And if pore pressure increases, this sigma dash, that is effective stress will reduce, which will in turn reduce the shear strength. So shear strength of the material will reduce if pore pressure increases. That is water pressure in the pores increases. Result, as U rises, that is pore pressure rises, sigma dash, that is the effective stress, available frictional resistance will reduce. Water is both trigger and a transport medium. So we can consider water as in three ways. One is it reduces the sigma dash, that is effective stress, and second one, it is a medium for the flow, and third one, I will go back to the previous slide. So resisting force will decrease as we have shown, we have seen, and driving force will increase because of water. Water will give more weight. So this is threefold actually. One is resisting force will decrease, driving force will increase, and water will act as a medium. Then this slide is very important. So let us start with conditioning. What is conditioning? It's a year, means long-term process. Geology and weathering, we cannot control that. Slope geometry, earlier slope geometry might be there, and old strips might be there. Weak layer discontinuities. Discontinuities are nothing but the joints inside the rock mass, land cover, and drainage setting. These are all prolonged, means long-term phenomena, long-term points. And these are actually 1 day or 2 days, means reason. Intense trigger, intense or prolonged rainfall, excavation and top cutting, load or muck placement, leakage and erosion, vibration. So consequences. What is the consequences? Consequences are what lies in the path. Workers, nearby residents, road, tunnels, and utilities, emergency access and resilience. So Kalladi question, which long-term conditions had already reduced factor of safety before the rainfall pulse? Now let us see the field warning signs that require action. Small changes are valuable when they are documented, compared, and linked to explicit threshold. Cracks. Cracks are actually not costlier, because means to find out the cracks. Even with the naked eye, we can see. I will show you a picture in one of the projects in Assam. See, this is the crack, tension crack. So it is visible, even if it is small, we can measure it by using some crack meter or something like that. So this is possible. This is it's not expensive monitoring. It's a very simple monitoring. We can see it with naked eye. Cracks, widening joints, road shutter tension cracks, then seepage, new springs. Suppose some springs are there, turbid water, muddy water, wet patches. These are all signs, actually, warning signs. Flowing fissures, deformation. If some trees tilted or wall distress, retaining wall distress, or settlement of some walls or retaining wall, something like that, and toe bulging. So these are all warnings. Raveling, fresh soil or rock falls, loose blocks, exposed roots. Drainage, blocked culverts, ponding, overtopping, diverted runoff. Acceleration, increasing crack rate, movement rate, or pore pressure. So all these warnings can be monitored very easily. So the action rule is signs plus rainfall plus trend. So that should be verified. Then restrict the access. Means people should not go there. Then stop work, evacuate when thresholds are exceeded. Now we talked about the mechanics, the physics. Now we'll talk about the ground. So the mechanics we covered. Next we will talk about the ground, terrain, geology, and slope materials. The same flow. So this right side picture, top picture, is the map of India I have taken from GSI. So these are the landslide prone terrains in Western Ghats, Himachal Pradesh and Jammu Kashmir area, and northeast area of India, northeast states of India. This is the world map. See here we can see that China having 1,250. This was reported in 2023. I took it from Zoo and colleagues paper. And India comes fourth from the last. Italy, USA, and India 207 landslides. So these are the literature from the literature I have taken, and there are 6 parameters we have to consider. 6 drivers actually. Let us start from steep terrain. High driving stress. Steep terrain means high driving stress in Western Ghats and confined drainage path, deep weathering, soil saprolite rock. We will explain. We will discuss this point. Transition and perched water. So these transition, soil saprolite rock transitions and perched water. Then intense monsoon. That's also a driver. Short duration peak plus antecedent saturation. Antecedent saturation is also important. Linear infrastructure, cut fields, portals, culverts, and concentrated runoff. Land use pressure, slope loading, vegetation change, and altered drainage. The last one is limited warning time, rapid flow transition, and access constraint. All these drivers are attributed to this slope stability. So, regional susceptibility does not prove site causation. It raises the standard of investigation, drainage, design, and construction control. In nutshell, I could say, I can say, susceptibility is not an excuse; it's an obligation. Yeah. Now we will talk about the laterite rock in that western Wayanad area. Actually, lateritic rock can develop from all type of rock, that is metamorphic rock, igneous rocks, or sedimentary rocks. It is actually formed based on because of the alternate what you call dry and wet condition. In tropical monsoon, long-term chemical weathering. It's actually chemical weathering. It's not physical weathering, just like that exposure to air and water. It is because of chemical weathering. Yeah, we talked about what wet and dry season, promote laterization. And the profile is commonly in situ over weathered parent rock, hard lateritic crust may overlay softer saprolite and decomposed rock. So I can say the layering like this. Top will be lateritic soil or stone, and below that very weak layer of saprolite, and below that weathered rock, and below that hard rock. Hard rock can be in our Wayanad, it can be charnocite, it can be gneiss, something like that. So I think it is mentioned here, yeah, whether gneiss, charnocite, and schist. Then this saprolite, the peculiarity of saprolite is that it is weak, clayey, and moisture sensitive. It can absorb water, and it can. Sorry, next one. This is lateritic soil overburden and slope stability. See here, hard crust can give false impression. So while drilling a borehole, if you have a rebound, and we should not stop there. Why? Because it can give a false impression of strength underlying saprolite that is very weak. Then jointed with parent rock further down, and fissures are. We will discuss that point. Then cut slope, expose the profile, remove confinement. If you cut a slope, then the confinement will be removed and allow rainfall to enter cracks, benches, and unsupported faces. So here there are 3 points. The last one is bolted blocks, boulders, and loose lateric debris can be entrained during slide. It can start as a slide. We discussed about slide. Then it can transform. It can transform to flow, increasing runout impact. So we have to investigate. The main point is to drainage. Drainage is the basic methods for making a slope stable. So without drainage, means in this type of lateritic areas, soil area, material area, we cannot make a slope stable. So here the checks for lateritic slopes, very important. Thickness should be mapped. permeability, seepage path, water table and storm response with the drain and piezometer. I think in Kalladi, I heard that there were no piezometers installed. Design portal cuts of global stability, not only face protection, combine nail sprayed conduit with drainage and toe control. Avoid uncontrolled muck placement. That's very important. On slopes or drainage lines, provide covered, lined, maintained surface drains before monsoon. We will discuss these points. So laterite is a useful material for construction, but in this type of area, the rainfall terrain must be handled as a variable, layered and water sensitive slope system. Unlike the material available in northeast states or north of India. Then this slide is also to be read very carefully. See, there are impermeable and permeable layers. So once the slope is cut, the hydrostatic the hydraulic gradient will increase, and there is a possibility of forming springs. So in our case, this is an example I have taken from Conforth, a textbook, in his textbook. So here the trapped head with the talus or bedrock, the permeable talus. Permeable means it can store water. So water is stored here, and the water can be raised above the ground level as well because of the pressure. So the mechanism is artesian pressure exists when groundwater head in soil rock is higher than the head in the overlying ground. It may develop where underground or groundwater from upslope is trapped below less permeable layer, just like this. When cut removes, that is when we make a slope, the hydraulic gradient increases and water may heave, erupt as a spring or trigger sliding or mud flow. It can start sliding and mud flow. All these should be actually forensic investigation. All these things should be considered. They should consider, obviously, I hope. Cuts approaching an artesian zone are particularly vulnerable unless excess pressure is relieved before excavation. It's very important point. Flow, seepage, heave, and sudden softening in a cut should be treated as pressure control issue, not only as a surface erosion. So you should not treat it as a surface erosion. So this is a conceptual model. See, there wet antecedent condition reduce the rainfall needed to trigger movement. So these are antecedent and even critical water content. So what is the critical water content? This is a conceptual model only. So for example, 200 millimeter already stored in a soil will be much critical than a dry for a 2-week dry the same soil. So the dry slopes may withstand high even rainfall in drainage is sufficient. Shallow failures can respond within hours. Deep failure can lag rainfall by weeks or months. So monitoring implication, rainfall gauges should be paired with piezometer. So that is very important. Not only the rainfall gauges, otherwise it will be a decoration only. It should be paired with a piezometer or groundwater observation wherever possible. Then human activity and slope risk. See, this picture is taken from Crozier a test article. It is in New Zealand. So this area is covered with forest and this is barren land. So what will happen there? Forest removal changes interception. It will change the interception. Then evapotranspiration, that's water gone to the atmosphere. Root reinforcement and runoff. So it will change finally it will change the runoff. Urban work changes slope geometry and concentrate water. So this point is not relevant for our Kalladi incident. Future risk assessment should consider climate and land use change together. See, this picture is interesting. Relationship between increase in water yield and percentage of forest clear felling. See, if it is 25% forest is cleared, then it will increase water yield to 100 mm. So it was earlier, it was 3000, suppose now it becomes 3000, more than 3100. Likewise. So So this is an article, and they have done intensive research from 42 catchments. Bosch in 1982. Now we talked about mechanics, then ground, then third section is investigation, monitoring, and risk. That is the proof. So what should be considered in investigation? Geomorphology. The scraps we discussed. Hummocky ground means small hills or undulated grounds. Old slides, earlier slides were there that we have to investigate. Drainage lines, path, runout. Topography, surface transport deposition geometry, and slope profile. Ground profile, fill or colluvium. Colluvium means nothing but if the material is weathered and it is static, then it is called residual. So it's the second one. If it moves to the foothill, then it is called colluvium. Weathered rock, sound rock. Joint discontinuities. Orientation. Joint orientation means you might be knowing uh, dip and dip direction. Then persistence. What is the length of the discontinuity? Infill. What is the material in joints? Aperture. What is the gap of the joint? And water condition. Groundwater seasonal level. Usually, in what I saw or I have seen in few number of investigation geotechnical investigation reports that they will measure the observed water during drilling only, but we have to see the seasonal levels, perched water, seepage, and storm response. Strength of the material, pre-drained, undrained, residual strength, selected by mechanism, construction strength, cut geometry, support, stockpile. All these should be noted in the investigation stage. See, this survey must go below the surface. First, I have considered, I have written remote sensing for surface data, image, topography, and deformation. This first one. Second one, this I have taken from Zhu and his colleagues. Optical image, then geotechnical parameter from the geology, means from drilling or something like that. We can understand lithology, structure, field features, and geotechnical context. Then geophysics. Further down, we can find what do you call seismic refraction or seismic reflection methods or some type of something like that. MSAW, a lot of methods are there. Groundwater and slips interface. Then finally, numerical assessment can be then check stability and dangerous zone. So my point is that a complete survey converts. A complete survey means from remote sensing to geophysics converts surface evidence to a defensible failure mechanism. Now let us talk about instrumentation. Measure movement and the driver. So this is something like a manometer. Is a this one piezometer, just like this. It will measure the depth of water. So there are different number of different type of piezometer, vibrating wire piezometer, standpipe, weir. Weir is not a piezometer, but we can measure the discharge by constructing a weir and spring discharge. Surface measurement, we can measure, we can use springs, prisms, GNSS, crack meter, tiltimeter, robotic throttle station. Surface movement, inclinometer and borehole extensometer locate shear zone. So this is, I will show you one picture. Yeah, GNSS. Yeah. So these are the countries. In USA, it is called GPS. They have installed. They have this service from 1978, and then Eurasia in 1982, and China in 2000, and in European Unions, then Japan, India. We have this facility from 2013, available regionally. Means few of the countries have globally as well. And GNSS means Global Navigation Satellite System. This is an inclinometer I have taken from Emil site, but I haven't written the courtesy. And this is a piezometer. Then trigger, automatic weather station, rain gauge and vibration sensor, system reliability. So telemetry. Telemetry means whatever the information we are getting at site, remote site, can be read from the offices. Local storage. So that is an important point. Power backup should be there. Calibration and storm inspections. This is our answer. Is just for understanding. I put this one. Defects active deformation level over large area, so that flow is there. Time series, ascending and descending orbit. Limitation for the SAR or INSAR is vegetation, radar shadow, phase decorrelation, very fast movement. Best use, screening and prioritization before field investigation, not final boundary definition. It's not a design tool, it's a screening tool only. Then threshold. First we detect, then interpret, verify, decide, communicate, then act and reset. So there are three levels of AAA levels. So that those levels are green, amber, and red in color. Green means normal monitoring, amber and enhanced inspection, stop work. Stop work is the last one, action level for monitoring and so threshold should combine rainfall, pore pressure, and movement rate, then be validated against the local response. So I will go with a little bit fast because 27 slides only we covered. So susceptibility. So this susceptibility to risk. So this is not a multiplication. It's a function, hazard function, and exposure function and vulnerability function. So risk is actually a combination of all these things. At a construction portal, exposure can be high even when the geographic footprint is small. So this is the event maps I took from Das. I think he's a Keralite, 2025 paper. Source area, flow path, deposit block channel, exposure, settlement roads, utilities, emergency access. We told exposure in the previous slides. Risk responses, evacuation zoning, debris flow barriers, drainage and warning system. Modeling. So for modeling toolbox, there are a lot of methods. One is limit equilibrium. We usually use in GeoStudio or RS2, Plaxis, etc. And that lot of methods are you are aware of that one. Jambu's method, Bishop method, lot of methods are there. Finite element RS2 or this is slide actually, not RS2. Slide or Plaxis we can use. Then finite different FLAC is one of the methods, one of the softwares. Rainfall infiltration model, it will give transient pore pressure and shallow failure timing. Runout debris flow models, velocity, depth impact, and execution zone design. Probability analytics. So there will be there won't be a single factor of safety, but there will be some reliability index or something like that. Most influential certain cities, groundwater condition, residual strength, slip surface geometry, construction sequence, and robust rheology. Out of these 5 points, only 4 points are related to investigation. So investigation should be considered with paramount importance. Only construction sequence is left with. So this is extreme rainfall can redefine susceptibility zones. I will skip this one. Forensic investigation workflow. So there are 6 drivers: secure document, map morphology by survey or LIDAR, reconstruct rainfall drainage, hydrology we have to reconstruct, investigation ground subs, boring test bits, etc. Then recover construction record. That's an important point. Back analysis. Then we can do back analysis by using limit equilibrium, FEM sensitivity, runout counterfactual. So a time sequence and mechanism model with uncertainties explicitly stated. Next one is tunneling portal risk in hilly terrain. We'll go fast. So I will discuss about NATM tunneling only. Why? Because TBM is not considered in this. Earlier they have not considered in Kalladi region. Stress release tunnel TBM means we are a new Austrian tunneling method. One of the tunneling methods used in tunnel excavation. So there will be stress release. Then delayed support. Suppose the support to arrest the collapse. If you delayed it, then that will trigger settlement. Then groundwater inflow. Similarly, for portal and keel slope response, portal cuts, toe unloading, drainage disruption. So this is for settlement. I will skip this one because this is for TBM settlement. And this for NATM, we can see controls. We can reduce the round length. How much quantity we have to excavate in one round. That can be reduced using pipe roofing or four-polling spiles, etc., face bolt and drainage holes, rapid rings. These are some remedial measures to reduce the excavation settlement. Settlement will cause slopes instability as well. So excavate, load, redirect water, vibrate, expose people. How construction changes the slope system. So here the main point is that temporary slopes, stockpiles, drainage path must be designed, inspected, monitored with the same seriousness as of permanent works. So that is missing in most of the projects. We'll read this only during TBM NATM portal works. Convergence and ground settlement should be measured. Phase mapping should be done. Inclinometer and crack gauge on slope should be installed. Then drainage outline and turbidity check, immediate upgrade of support or short rounds or closure. What are the observation? What typical immediate action we can take? Rapid increase in settlement or convergence rate. Post excavation, review support class, increase grounding and reduce ground length. So these are some remedial measures. I think I can share the slides, Anna, madam, so that the people can read through.
Yes, sir. Later, this can be read in a later stage since we
Yeah,
have
yeah.
few
Yeah,
time.
yeah.
Maybe we can skip to the Kalladi's
Yeah.
slides.
So next five, there are 7 divisions. So the fifth one is mitigation. There are 45 toolbox means methods. So I will skip this one. We can read later on. One point I would like to highlight is that out of these 45 methods, 13 methods are related to drainage and dewatering. So from this, we can understand how important it is. So I have mentioned all the methods, mitigation methods. So this I will skip. So here I would like to say something. So soil nail. Soil nail here, if you put the soil nail not extending up to the slip circle, then there is no meaning. There is no meaning. It's only a decoration. So this should be extended behind the slip circle, and it should extend to the competent material. That is what I would like to highlight here. And this mechanical previous grouting phase shooted and moderate. Okay. Now we will see these are the 30 to 43 methods, 44 to 45 methods, and then where to use, what method to use under which condition. So this I have explained, I tried to explain here in this slide. Then Kalladi, this is the case actually. So we know all these things. So it happens in July 7, 8 reported deaths, 9 reported injuries, and the contractor says it is because of natural calamity. I will just show this letter from the contractor to BC Limited. They mentioned that it is because of natural calamity and 2065 of rainfall in 24 hours. So here my point is that we have to see the antecedent weather as well. Not only the 265 millimeter in 24 hours, we should consider the antecedent water also. So in the forensic investigation, that should be considered. Timeline. So I will skip this one. human operational, I will skip this one. So Kalladi event, 5 interacting system. There are 5 interacting system. One is terrain. We discussed about the terrain. It's a weathered or overburden, steep relief, joints, all the geomorphic features. Second one is rainfall and rain and construction, water intensity, antecedent wetness, infiltration, runoff, and pore pressure. Exposure. A lot of people plant access below the slope. Then governance, whether stop memo has been given properly, or those type of things comes under governance. Construction is portal cuts, temporary slopes, muck, drainage changes, and sequence. Subject to the findings of the official expert committee. Competing, so there are 2 type of arguments. There are 2 arguments. One is it is because of natural slopes calamity, unsloped landslide, and upsloped landslide, and second one is construction linked or preventable failure. So these are the 2 arguments. So let us see in detail. So contractor says that it is because of natural calamity. Evidence to test. What are the things to be tested actually? Crown, source, location, and continuity. Natural colluvium, paleoslide means earlier geometry, runoff and groundwater path, failure volume and runout mechanics, whether construction changes were outside the initiating mass. Interpretation B, pre-failure cracking, seepage and inspection records, portal cut, temporary slope geometry, muck placement, loading and muck placement. This is important. Where so usually there will be some identified locations for placement, muck placement. Drainage, blockage, and concentration, whether stop work threshold existed and were applied. All these points should be checked if you go with the interpretation B. Forensic investigation must establish means they might have considered this one. So I will skip this one. So this is important. So if in the beginning stage it is stable, heavy rainfall, then persistent rainfall, it can be marginally stable. Then finally it becomes unstable, actively unstable. Failure and factor of safety is mentioned with respect to time. So these avoid okay, just skip this one. Okay, so this question is actually optimization. Did optimization reduce portal slope safety margin? So this should be examined. Adopted slope geometry and benching, soil line length and effective stable bond length. We discussed that one. It should cross behind the slip circle. Sprayed conduit thickness, mesh and novel head detailing, surface and subsurface drainage provisions, instrumentation for displacement and pore pressure. And whether risk controls were reduced. Temporary works and monsoon stage protection. Temporary works we discussed several times. Independent design review should be there. Level site presence by the designer. Trigger-based authority to pause or escalate works. Decision not to introduce heavier support after distress support. So the key question is whether optimization changed the portal form from a robust geotechnical system into a minimum surface retention scheme, leaving inadequate margin against saturation. So saturation is very important, distress and progressive failure. So it starts as it may start as a slide, then eventually it becomes a flow. Construction sequence. This is also very important. Usually in a tunnel portal area, before monsoon, we construct all portal stability measures, including drainage, everything. After that only we enter into during monsoon, during the time of monsoon, we should enter into the tunnel. So that construction sequence also should be checked thoroughly. Because in monsoon season, nobody will work on the portal. That is the usual practice. So the contracted sequence appears to have carried incompletely stabilized, inadequately drained portal excavation into the monsoon. This likely aggravated the slope vulnerability. This is obvious from the reports. That's what I highlighted this point because that happened in monsoon only. When intense rainfall increased pore pressure and internal erosion, final causation should be confirmed by the expert forensic investigation. This we already discussed. What soil nail, mobilized tensile strength, that is okay. Ties the sprayed concrete facing correct. But what it cannot do, it cannot safely resist a deeper slide surface. We discussed this point. It cannot reduce pore pressure unless drainage is built. So drainage is very important. So out of the 45 mitigation methods, 13 are related to drainage only. So Kalladi lesson, soil laying at the portal should be judged as a part of the full system. Portal excavation sequence, slope drainage, toe support, instrumentation, and monsoon stop work threshold. So the last session, from findings to action. We should that in the preventive measure already done, people are already define control access with one side command, drain safely, stabilize it temporarily, monitor continuously, preserve evidence, take an action. So do not start permanent stabilization until the source geometric groundwater pathway and failure depth are sufficiently established. Emergency response, all those things within 1 month, they might have done it. Medium stability, hydrology should be studied, geometry should be studied, resistance, buttress, piles, nails, or whatever possible things, run out, debris retention, protected channel, exclusion zone, and road closure logic. Verification, instrumentation, and performance threshold throughout the construction. Concept only, final arrangement depends on the expert's committee. So, sorry, only few slides are left. So this I can skip. So monsoon hill tunneling should have been stopped actually. So that is one of the reasons I found, I think. So practical conclusion is, for hilly tunnel projects, portal stabilization complete should be treated as a mandatory milestone before monsoon exposure. If completion is delayed, the correct response is not to wait with the slope exposed. It is to secure drainage, reduce loading, remove people and plant from the runout zone, and suspend work until the risk is demonstrably controlled. Yeah, this is the action plan. This you can see later on. So my last point or final thought is, India needs tunnels, mountain roads, and other infrastructure in challenging terrain. The lesson is not that fragile landscapes should remain undeveloped, but that development in difficult ground must be guided by rigorous investigation, conservative design, robust support, effective drainage, continuous monitoring, and timely intervention, not by optimistic assumption. So the point is that difficult ground demands stronger engineering, greater vigilance, and timely decisions. So these are the reference I took from the literature. These are the reports, means papers, e-paper, etc. And the last point is, let us strive to establish a safer and more resilient future. Thank you.
Thank you. Thank you so much, sir. It was an in-depth presentation we were having today. And thank you so much for that in advance. And at the same time, we know that due to time constraint, you might have skipped some of the slides, which we will be seeing in coming question answer sessions, we hope.
Yeah.
So there are few questions in the comment box. At the same time, is there anyone who can ask by unmuting yourself and directly to Vijayakumar sir? That is well appreciated, because this is a platform for interactive sessions. So any questions from audience, please do come forward and ask directly. Dear participants, please come forward and ask questions. No worries, in your own language, no issues.
Divya, I think there are some questions in the chat box.
Yes, ma'am. At the same time, any additional questions? Okay, please be prepared. At the same time, we will ask the question in the chat box that there is a question from unknown member. Can you please rename yourself so that we will identify at least your name? The contractor is saying 12-meter drainage holes are installed. Do you have any comments on that, sir? Vijayakumar sir, to you.
Yeah, drainage holes are installed. That actually should extend behind weep holes and drainage holes are different. That everybody knows. If 12 meter is there, it is wrapped and it should extend behind the or the entire mass in the within the slip circle, and the slope must be drained. That is the actual that is the important thing. If we put drainage hose that is not covering the entire mass, then there is no point in the drainage will not be effective. So 12 meter, we need to understand the slips, the slip circle where it actually is failed the failed surface. Then only we can understand whether all the entire mass has been drained or not. But as per my understanding, the report says drainage piezometer was not there, but drainage holes might be there. Piezometer was not there to measure the water level.
Okay, sir. Thank you so much. Hope he had addressed your question, sir. At the same time, your name you have mentioned as Mr. Ajay, geotechnical student. Well, appreciate that you are coming forward and asking question. And he's also asking one more question, like BSI letter is saying, work was stopped at the end of May itself. That you were mentioning about postponing the work during monsoon seasons for such kind of rigorous works, and he's saying that based on his own knowledge, it has been stopped at the end of May itself. Was it true, sir?
But as the reports available with me says, I mean, a lot of people are so there, machineries were there. That is all reported in newspapers. I'm not sure. I think this is what do you call relevant or not, this information.
Yes, because
No.
we even in the media videos we were seeing like the works were going on at the site.
Yeah.
Next is, sir, how to differentiate between superficial cracks and risky cracks in the open area of an excavation? One of the participants is asking, requesting you to mention your name. Thank you. To you, sir, Vijayakumar, sir.
Could you please repeat what was the question?
The question is how to differentiate between superficial cracks and the risky cracks in the open areas of an excavation.
Yeah, understood. So tensile tension cracks. Can I go to that sheet again?
Sure, sir.
Yeah. So it is not means my understanding is that it is not the crack should be monitored continuously. If any further movement is there, that is a risky crack. See, this crack is earlier it was very small, very minor. Then it expands. This tension cracks expands. Now see the width of the crack. So this means in due course it will fail. So it should be monitored continuously, not in means we should by naked eye also we can see that. So earlier it was a very small crack, then later on it becomes like this. So continuous monitoring is required.
Sir, to add on to this, usually, especially in the case of retaining structures, the vicinity of it, due to the poor soil filling, we will be able to see some local movement or settlement. At the same time, we will be seeing this visible cracks as well. So as you said, when we are monitoring this progressive cracks, when should we will be very vigilant about it, sir, whether we should focus on the lateral movement of the retaining structure or just by visible cracks seen on the filled earth?
No, sorry for interrupting. Actually, should I close this one? So there are a lot of things actually. Means we mentioned in the warning, is here widening joints, and here also distress, wall distress, settlement. All these are actually warning signs. If these are actually related, cracks and seepage, deformation, so these are medium, and this is the worst condition, drainage and acceleration. So my point is, I think I have explained properly, or should you need any clarification?
Yes, sir,
on
it
this?
is enough. This is good to go. Admin, can you please allow the participants to unmute by themselves and ask the questions, please? admin? Can you hear me? Okay, so for time being, we will be working on it and we will allow you to speak, sir. Please, just a minute. There is one more question. If the slip circle is of a very large radius, then is it possible to soil nail? Is there any limit of length of soil nailing?
Yeah, that's a good question actually. But slip circle, it will be a global failure then. Means there are three type of failure: local failure, failure, and toe failure. So this will becomes a global failure. So I don't have the photos now, but in Assam we found one hill actually moving. One hill part is moving. So the three layer of roads are moving together. You cannot imagine. I have that photo. I will share with these slides. So it is a global failure. So we cannot use any soil nail there because three layer of roads, three layer, one layer, two layer, and third layer that consists and all the hill is moving actually. So what I realized that there are no people living. It's a no man's area. So they understood earlier itself that the hill is not capable, is suitable for living. So when they construct, the contractor construct the roads, all are moving actually. So there are some other methods. For example, the drainage is the best option. So in one of the locations, we drilled a what you call a well with connecting horizontal tunnels. Then we drained the water actually. So the soil, once the drainage is main culprit, so the water is the main culprit. So if you drain it properly, then the slope can be. See, today dry condition it is safe. Tomorrow in the wet condition it may not be safe. So that is the point. So we have to proper drainage should be given so that the further movement will not be there. So soil nail in that kind of situation obviously will not be advisable, not possible as well. Hello.
Yes, sir. Yes, sir. Of the question is addressed, like inside the tunnel, there is one more question. If the crack is crack in a confined area is within the tunnel, how to address it? Is that the question?
Inside the tunnel, not at
Inside the tunnel.
portal.
Inside the tunnel, yeah.
Okay, inside the tunnel, cracks means there are a lot of possibilities. One is wedge, just like slope wedges. So there may be possibility of wedges that can be come out. So there may be some cracks or some shear zone will be there. So it depends upon it depends case to case actually. For sometimes it can be divided. It can lot of method will be there. For example, the swelling will be there. Then flowing will be there. So a lot of different, we have to address differently. For example, shear zone, we will stitch it with rock bolts from one side to the other side and then the other side to this side. So we will stitch with rock bolts. I think if you can refer 15020 IS code, all the methods are explained properly.
Yes, sir.
And that is for the primary lining. For inner lining, we have to use conduit and reinforcement so that the final shape will not be affected.
Yes, yes.
So I have a question.
Yes,
So good evening, sir. So I'm a student, geotech student. So I have a few of my queries regarding this project, sir. One question is about the two arguments you are saying that about whether it is a man-made or it is this natural disaster. So for the natural disaster, you told that main point is that we have to check about the main crown and the source of location and the continuity, sir. This is the one of the points. I don't know whether you might have gone through the different reports from the different geotechnical scholars and those belonging to the tunneling scholars. They have mentioned that this particular point is out of this project area. It is almost coming 100 meters. Some are reporting it is 100, some 150, and some are saying it is 80, 90, something like that. So the contractor in the same extent is arguing about the that this is actually the natural disasters. So could you put some light on this particular issue, sir?
Actually, for finding, you are talking about interpretation A, right?
Yeah, yes, sir.
Yeah. So this point should be tested actually. We know the crown, source, location, and continuity. That is not finalized yet, not found out yet.
That's actually found. That's based on the different scholars on the basis of Google Map and all that. They have
No, actually, sorry to interrupt. We have some other evidence investigation methods actually we discussed. So based on that method, actually, it has to be found out actually. Then natural collivium or paleoslide geometry, that also to be found out. Whether earlier earlier slides were there, that is also we don't know. And one more point, it may start actually a slide. It may start with actually as a slide movement. Later on, it becomes flow.
Yes, absolutely. Second thing you mentioned in your during the presentation, you said that if it's a catastrophic type of the issue, then what is happening that the flow is in a meters per second type of this. But whatever the reports we have gone through, we have seen that they are claiming the contract itself is claiming that the distance covered by the debris is almost 500 meters. Some are saying 600, some 700, but we can minimize it to the 500 or 400. They're saying in the 400 meters it has covered in 4 or 5 seconds. So in that particular, it is one of the argument from the contractor side, sir. Any so what is your views about that?
Actually, we discussed that one. Maybe I can go to the previous slide. Yeah. So this slide, a slide means having a rupture surface can become a flow later on. And this this loose material in the middle or within these two movements also flown. And not only that, the everything. So the slide becomes flow or debris flow. So that is why the material it has started as a slide, but later on all the materials in the en route, all the materials en route, and the water also. So that becomes a flow debris. That is why the total height means you are talking about the volume of material or height of material, volume of material, right?
Yeah, yes, absolutely. Some more volume of material, sir.
Yeah. So the volume of material increased actually on the en route. It increased because the loose material on the way it acts as a fuel actually.
Yeah, so my argument is whether the contractor who's claiming that it is a catastrophic, whether it is the only one scale where we can measure the catastrophic flow in this way, or we have other means also. We can just check some of other points regarding the catastrophic flow or some landslide or man-made disaster.
Actually, in totality, we have to see, we cannot support a one argument. Why? Because the other argument, people also have, officials also seeing the second argument. So after forensic investigation only, complete the forensic investigation only, we'll be able to come to a conclusion. See, this second point also kindly go through. Because
Admin, can you please mute the other participants? Mr. Minshit, can you please mute your mic? Minshit?
So the
Admin, please take the charge, okay? Yes, sir. Please proceed, sir. Sorry.
So other arguments, the interpretation B, that also to be considered, mark placement was there as per the report. So there should be some defined, demarcated location for mugs. Even in the forest area, we usually, when I was in Kerala, working in Kerala, we usually consider some amount for firewood. So that means we should not cut even one small top, means what you call branch of trees. So there should be some fuel, means what you call firewood amount also to be considered in the estimate. So that much environmentally it should be it is clear actually. So mark placement should be in a designated area only. So they will argue with that point.
Uh,
And
so, so- sorry to interrupt you, sir. Actually, another thing that in the media itself, so when I heard this Kerala chief minister, he said in this report that earlier there was some confusion that some mud disposal is on that side, but later on he clarified that this mud disposal is not there. It is not because of that. So this was one of the news in the I have seen in the news, sir. These arguments, I don't know whether the committee how they are
yeah,
going through these things and all that. So you also what I got from the overall this PPT, I feel that it is the final is the expert committee or the technical this legal committee. They will be the final authority who will give the final comments. Sir. Is it like
yeah.
that, sir?
Yeah, and one more thing I would highlight is that the forensic investigation, what are the things they usually consider? To what forensic investigation must be established? Where did rupture initiate? So far, I think that is under investigation. What was the movement mode? Slide, debris flow, complex transition, or progressive collapse? How did this actually? I think we skipped actually. Sorry. How did water act? Rainfall history, antecedent water, seepage, pore pressure, drainage concentration, and erosion. What did construction change? Geometry, loading, toe support, drainage, and material pathway. What warning existed? Whether they were cracks, turbidity. Well, we discussed actually warnings, warning signs, deformation, inspection reports, and decision logs, and whether they stop memo was there. That also, all those things which could exposure have been reduced. Work location, exclusion zones, stop work rules, and evacuation readiness. So all these points usually in the forensic investigation, the committee should consider.
Okay, so thank you
And
very much,
after
sir. It
that,
was
Thank
very nice. It was a
after
very
that,
very nice.
yeah, after that only we can come to a conclusion.
Yeah. So thank you very much, sir. It was a very nice interaction with you, sir. So my humble request is whether we can get this PPT, sir. It's a very beneficial PPT.
Yes,
Is it possible?
sir, you can please be in touch with any of us. We will share the PPT just after this presentation, after verification, sir. Definitely, we can share it.
Thank you
For
very much. ma'am.
sure.
Thanks a lot, man. Thank you.
Yes, thank you. And thank you, Vijayakumar sir. We will move on to the next question. There is a question from Nasrin sir from Matter Lab. So would you like to unmute yourself and ask, or should I ask the question? Nasrin sir? Yes.
Yeah.
Hello, sir. Good
Yes,
evening.
yes, ma'am. Good evening.
Good evening.
Sir, actually, my question is there are actually many cases in slope stability and all. We have heard about the even if the drainage holes are being present, there are blockages happening in the particular drainage holes. That is the reason why, because it is the drainage holes are being installed, but it is not been in proper usage. So is there any methods like we can monitor it like that in the whole procedure of that construction or something?
Yeah, actually the pipe, we are using perforated pipe. Usually we use perforated pipe. Usually it is wrapped with geotextiles so that no material will be, means material which is blocking the pipe will not be allowed to enter into the pipe. So
Okay.
usually we wrapped with the geotextiles. So if it is not wrapped with the geotextiles, the designed geotextiles, then there will be a possibility of blockage.
Oh, okay. If so, you're saying that if it is blocked, it is not installed in a proper way.
Proper way, yeah.
Okay.
Usually, once in a maintenance period, they have to inspect the holes, and we have to remove the blocks if any. by or removing the pipe or re-drilling, something like that. Once in a means a while, means not regularly, but maintenance usually people do like that, because this pipe may not they're durable for say 50 years or 60 years. So during maintenance it has to be removed, and we re-drill and re-establish the pipe with geotextile, perforated pipe with geotextiles.
Okay, sir. Sir, in some highways, while we are traveling through Kerala, we have seen that the slope has been cut, the things are being installed, but the slope has been like left open like that. That also may be a cause of this slide, not in this case, but I'm asking about the highway case.
What material you witnessed there, madam?
Sir, actually, while traveling, we can see the open excavation, like the cut slope there, and we can see the drains installed inside. But we have seen without shotcrete, nothing like that. We have seen like just cut open slopes, so that can lead to a slope failure, right?
And actually, madam, we will usually in the design, once we cut a slope in the, for example, whether it limit equilibrium analysis or means stress reduction method, we usually cut the slope with and give the find out the factor of safety without giving any support. Find the factor of safety without giving any support. If it is usually there will be benches in between, 6 meter or 6 meter or something like that. The code says 6 meter, I think. So the benches will be there, and if it is stable, then usually the minimum support only we need to give. Otherwise, for example, if it is rock, charnocate, then 1 in 10 is possible actually. If we can cut 1 in 10 as well, no need of any support. Only thing is that shotcrete might be required to avoid falling of small pieces. So shotcrete we will use some what you call wire mesh and a shotcrete, so that small pieces may not fall to the floor, means a lower level.
Okay. Okay, sir. Thank you. Thank you so much.
Thank you, ma'am.
Thank you, ma'am, and thank you, sir. And we have next question from Anil Kumar, sir. Sir, would you like to ask directly?
You can, ma'am. Sorry, no worries.
Yes. So the question is Western Ghats in Wayanad region is suitable for tunneling work? That is a basic question everyone is asking and keenly waiting to hear from you, sir.
Okay. So I will show the last slide. Maybe that might be the answer. Okay. Is it visible?
Yes, sir, very much.
So we need tunnel actually. And optimization, we should not go for optimization. We should do in rigorous investigation, conservative design, robust support, effective drainage, continuous monitoring, and timely intervention. So even in northeast states, the Himalaya is the youngest mountain. Everybody knows that. So there we are doing tunneling, no? And we are doing tunnel in Jammu Kashmir, all this fragile area. Youngest mountain, and in Kerala, only the lateritic soil and monsoon is the culprits. But the charnocate is strong, whereas in Himalayan region, every 1.5 meter, the geology changes. So we need tunnel, sir.
Okay.
Thank you, sir, for posting
Okay,
that wonderful question.
Okay.
Okay, so we will go to the next question. Sir, the question is, could consolidation grouting strengthen the excavated slope of the Kalladi location? He's asking about the consolidation grouting.
Actually, it is clay, means clay soil. Usually consolidation grouting around the tunnel we usually use consolidation grouting if the rock if the rock is fragmented. But in Kalladi area, laterite soil, I am doubtful because because it is clay material, no. So maybe chemical type of things might be suitable, but it will be costlier.
Okay, it depends on the cost, right, sir?
Yeah, cost and the material, how the sieve analysis, hydrometer analysis, etc. might be, etc. should be carried out. Then only
Okay.
we can come to a conclusion that what type of grouting is possible there.
Yes. Okay. If anybody is having some important question, you can raise your hand. Then we will unmute here. The next question is from Dr. Suresh Babu. Was there any stream on the top of the Kalladi tunnel mouth location? If there is a stream, whether the contractor considered this an adequate drainage was constructed to capture the spill over water during the rainy season? Was there any stream on the top
Yeah,
of the
actually,
Kalladi tunnel?
from the reports, I couldn't see any point related to the existing stream or existing springs or streams there, but that comes under forensic investigation. Was there any stream or was there any springs, and whether it activated the slides, and then it turns to flow. That all those points comes under um, detailed forensic investigation. Means as of now, I couldn't see any reports that is mentioning about river or streams upstream of this landslide.
Yes, sir. Thank you so much. So there is there is a question from Sakir Hussain, sir. What is the maximum slope to be given in soft lateritic cutting?
Okay, so I will go to one slide. So the mechanics. Yeah. So the factor of safety, it is based on factor of safety, sir. So the factor of safety is resisting force divided by driving force. So the resistance can be from C dash, the obviously it is lateritic soil, 5 dash, etc. But let us think about demand. So the slope angle you are talking about, but it depends upon height and what is the unit weight, whether the surcharge is there, erosion. All these factors we have to take, and we have to find out by using limit equilibrium method or FEM method, FEM. Then we will come to a conclusion that this slope is okay. Or then otherwise we will, what we usually do, can I use my paint, madam?
Yes, sir. Yes, sir. Everyone, please note we will be concluding in 5 minutes time. So if at all any question is there, immediately post it, or otherwise we'll be addressing in a later email or messages.
So suppose, sir, this is the slope you want to make. There are some constraints. We cannot go behind this. This is the slope. So what we usually do, either we have to reduce the weight. Reduce the weight by means it means that we have to provide a bench. So this weight is removed. A bench is there. So likewise, the slope can be maintained, but it depends upon this is usually 6 meter. So what is the slope? The simple answer is that it depends upon the height, material properties, surcharge. Suppose some road is there, some road is there. So the road is there, some road is there, and vehicles are moving. So all these points should be considered to arrive at a conclusion that what slope angle we can maintain. It cannot be answered in one word. Why? Because lot of parameters are there, and if some water pressure is there, then we have to. This is suppose the phreatic line, and we have to remove the water by using drainage hole or something like that. So in one word, we cannot come to a conclusion that this slope is the right slope. It depends upon the height to be excavated and whether the surcharge is there, what is the phreatic line, what is the material property. Yeah, obviously it is lateritic soil here. So that is defined, but rest of the things are to be considered while arriving a slope. If it is again making unsafe, then we provide the support either by soil nails or by something like that. It should close the slip circle. the soil lines. And this shotcrete is it is high shear strength it has, but usually use it for avoiding small fragments, falling of small fragments into the portal area. So usually we use shotcrete and rock ball together. Here also shotcrete and rock ball together. So in one word, we cannot say and answer that, sir. It depends a lot of factors.
Okay, thank you, Vijayakumar.
Thank you, sir.
In many of the projects, highway projects, the land is the issue. So there may not be sufficient width for giving that benches or keep the sufficient slope. I have seen many places this 10-meter vertical height laterite in a structure, simply 10 meter. But it is really I am afraid of seeing it.
Yeah.
So in
So-
our Malappuram district also recently we have seen some slope failures like this. Then site availability is the problem.
Yeah, ROW is the problem. In that
Yeah.
case, what we usually do, either we put a buttress here. Buttress, or finally, if you make retaining wall, it is very costly.
Yeah.
But otherwise, buttress will support it will give a passive pressure.
Okay.
Thank you.
Thank
Thank
you
you,
very
Saki Hussain sir. Thank you, Vijayakumar sir. So there is another question. Which type is most suitable, NATM or TBM or any other type?
Okay, so that is the subject is different, but I can answer that one. TBM means tunnel boring machine. For example, if a 2-kilometer tunnel is there and bringing a TBM, it is not feasible because its cost itself is more than 100 crores. Real TBM, but Chinese TBMs are available with the 30, 40 crores. But 100 crore is the minimum standard TBM for getting a standard TBM. So for 2-kilometer long tunnel, obviously the TBM is not feasible. And suppose 2 kilometer is there, then at the tunnel after say 300 meter, another tunnel is there. Here also movement of this tunnel, TBM from this location either by road or we have to drag it. All these things are to be considered, and accordingly we have to take a call whether TBM or NATM is feasible. Because for a shorter length, it is not feasible, but longer length, if we have done in Kishanganga, the total length is more than 14 kilometers. So per day or per month we got around 900 meters advance. But whereas if you do that NATM, the pros and cons are there. So 900 meter per month we got actually advance. But if it is NATM, it will take 2 years. So these are the considered. But whereas in small tunnels, we cannot go for TBM because of its cost.
Yes, sir. At the same time, we have recently heard that India had developed our own tunneling.
Our own tunnel boring machine, right?
Yes, sir. So because of that, is there any change in expected cost for this particular
No,
tunneling
madam,
process?
because the tunnel boring machine, the basic cost remains same.
Okay.
And because and more than that, we are doing one tunnel in Mumbai. It's 12-meter diameter, tin tunnels. 12-meter diameter means more than 4 floors height, around about 4 floors height, and it is running from Orange Gate to that Marine Drive. So we are designing that, madam. So that location is possible because the length is more than 8 kilometers. Total length is 8 kilometers. But for a small tunnel, it is not advisable and feasible. And small tunnels, and in between in some places, if you go with the road, open level, means at grade road or railway, then in that case, again, we have to shift this tunnel boring machine to this location. That is very much costlier. Because tunnel boring machine will not be moved, will not be shifted in one go. It will be pieces. So the cutter will be there, a reaction frame will be there, then it will enter, then the next module will be connected likewise. So
Yes.
shifting is also a problem for
Yes,
small tunnels.
Yes, sir. Yes, sir. Thank you, sir. And there is one last question, and I think this is a person who is very well aware of the technical details of our own Kalladi tunnel. He's
Okay.
asking a question. It is having about 8 kilometer. Is it possible by TBM? 2 tubes each 8 kilometer. Is it possible? He's asking, and also he's asking for the suitable shape for Kalladi tunneling work.
Yeah. Actually, 8 kilometer tunnel, it is possible. TBM is possible, and you are talking about usually this TBM tunnel will be circular. In India, it is circular. Most of the areas it is circular, but in China they developed not a circular, but something like this. A irregular shape, not circular exactly. If we can, you can Google it and we can find it out. But in India and rest of the world we usually use circular TBM. And for hydro tunnel, I would like to say the circular will be very much effective. Why? Because its hydraulic radius is more. That hydraulic people can understand. And for deep tunnel circular is good. Why? Because bending moment will not be there, because the condition will be hydrostatic. Hydrostatic means pressure everywhere. Deep tunnel, the pressure will be hydrostatic. Everywhere the pressure will be there, remain same. So there will be axial force only, no bending moment. So that will be suitable. Circular will be suitable. But for road tunnel and railway tunnel, circular, if you make a circular, then we have to fill it with for vehicular movement. So usually we do a half type of things. This horseshoe, it is called horseshoe. Then we make a flat or something, a small circle like arc like this. So it is called horseshoe. So horseshoe is suitable for road and other type of NATM tunnels. But for TBM tunnels, usually we go with circular shape. And for example, some adits connecting tunnels and tunnels, or cross passages, or for suppose there is a tunnel, I will raise this one.
Yes, sir.
Yeah. For example, a tunnel is there, and it is an ATM. We cannot take the muck from here every time, or the entry or exit. So we usually drill an additional tunnel. So these locations, from this location is adit. So this shape is only for movement of vehicle. It's not neither for taking the muck out. So this tunnel will be of smaller size, and we sometimes, if the rock is good, then we go with the D shape. Some right side wall, left side wall, and upper one arc, something like that, semicircle or something like that, D shape. But for road tunnel and railway tunnel, bigger tunnels, larger tunnels, we usually go with horseshoe shape. And for TBM, it is circular. Circular, the advantage is that for deep tunnel, not for shallow tunnel, there won't be bending moment, will be very less. Axial force will be acting. So the conduit can inner liner means the conduit and reinforcement. The conduit can take maximum compressive force, axial force, and the reinforcement will be very minimal. I think I answered it properly, I hope.
Yes, sir, hopefully. Thank you so much for posting such wonderful questions. And thank you so much, Vijayakumar sir. At the same time, I'm requesting Sushindu ma'am. Sushindu ma'am? Sir, maybe you can stop slide sharing. And over to you, Sushindu ma'am. We are coming to the conclusion of our today's session.
Thank you, ma'am. May I audible?
Yes, ma'am.
Okay, good evening, all. Thank you, sir, for your wonderful section. I would like to extend my deepest gratitude to our esteemed resource person, Vijayakumar sir. Thank you, sir, for your sharing your valuable insights and expertise with us today, making this seminar very interesting and meaningful, and cleared all our doubts, especially it's a wonderful interactive, active question answer section. So many participants asked so many questions, and you cleared like a simple teacher with pen and using paint. Thank you so much, sir. And thank you all the engineers who have participated and making this webinar more great success. And thank you all once again for your valuable time and participation. Thank you so much, sir. Thank you. Thank you,
ma'am.
ICC,
Thank
for organizing a wonderful session, sir.
Thank you. Thank you,
Thank you.
Vijayakumar,
Thank you.
sir, wholeheartedly
Thank you, ma'am.
thanking you. And we are
Thank
very,
you.
very happy and privileged to have you with us. And we will be
Thank you,
having
ma'am.
more such interaction with you again.
Yeah.
Hope we will meet you again in our
Thank you,
September
ma'am.
15th event.
Yeah.
Thank you
It's
so
a
much.
nice
Thank you, everyone.
interaction, actually.
Yes,
Nice
sir.
interaction. Yeah.
Thank you,
Yes.
thank you, sir. Thank you, sir.
Thank you. Thank you, ma'am. Thank you. Thank you, sir.
Thank
Thank
you.
you, sir. This is Sriram.
Thank you, sir. I think there are so many of your friends and colleagues attending today's session.
Yeah, yes, ma'am.
Yes. Thank you so much. And good night to all.
Thank you. Thank you, Vijayakumar, sir.
Thank you.
Good
Thank you,
night,
sir.
good
Thank
night.
you. Good night. Good night. Good
Thank
night.
you,
Take care.
Vijayakumar, sir.
Yeah, thank you, sir. Good night. Take care.
Okay, good night, Vijay, sir.
Yeah.
Thank you.
Thank you, sir. Thank you. Thank you. Thank you.